Welcome to our exploration of oxygen, one of the most vital elements on Earth. Oxygen is all around us, making up about 21% of the air we breathe. Without it, life as we know it simply wouldn't exist. In this video, we'll dive deep into the world of oxygen, uncovering its properties, its role in our daily lives, and why it's so essential for both plants and animals. Let's begin our journey by understanding what oxygen really is, and why it's called the element of life. Story of oxygen's discovery is both fascinating and a bit dramatic. In the late 18th century, several scientists were racing to uncover the secrets of air. Joseph Priestley, an English chemist, is often credited with discovering oxygen in 1774. However, Swedish chemist Carl Wilhelm Scheele had actually produced oxygen a few years earlier, but his findings were published later. Anton Lavoisier, a French scientist, later named the element oxygen and explained its role in combustion and respiration. This discovery changed the way we understand chemistry forever. Oxygen holds a special place in the periodic table. It's represented by the symbol O and has an atomic number of 8. As a member of the chalcogen group, oxygen is a nonmetal and is highly reactive. Its position in the periodic table helps us understand its chemical behavior and why it forms bonds so easily with other elements. This reactivity is key to many processes, from rusting iron to supporting life through respiration. Let's take a closer look at the physical properties of oxygen. At room temperature, oxygen is a colorless, odorless, and tasteless gas. It becomes pale blue when liquefied at extremely low temperatures. Oxygen is slightly heavier than air and is not flammable, but it supports combustion, meaning it helps other things burn. These properties make oxygen unique among the elements and crucial for various industrial and biological processes. Oxygen is known for its high reactivity. It readily forms compounds with almost all other elements, except for a few noble gases. The most common compound is water H2O, where oxygen combines with hydrogen. Oxygen also forms oxides with metals and nonmetals alike. This reactivity is why oxygen is so important in processes like rusting, burning, and even in our own bodies during cellular respiration. Respiration is the process by which living organisms take in oxygen and use it to produce energy. In humans and animals, oxygen is inhaled into the lungs, where it passes into the bloodstream. Cells use oxygen to convert glucose into energy, releasing carbon dioxide as a waste product. This process is essential for survival, as it powers every function in our bodies from thinking to moving. Plants play a crucial role in the oxygen cycle. Through photosynthesis, plants absorb carbon dioxide and release oxygen as a byproduct. This process not only provides the oxygen we breathe, but also helps regulate the balance of gases in the atmosphere. Forests, grasslands, and even ocean algae are all vital sources of oxygen for our planet. Oxygen is a key component of water, which covers about 71% of the Earth's surface. Each molecule of water contains 2 hydrogen atoms and 1 oxygen atom. This combination is essential for all known forms of life. Aquatic animals rely on dissolved oxygen in water to survive, and the water cycle helps distribute oxygen throughout the environment. Earth's atmosphere is made up of several gases, with oxygen being the second most abundant after nitrogen. Oxygen makes up about 21% of the air, providing the perfect balance for life. Too much or too little oxygen can be harmful, so this balance is carefully maintained by natural processes like photosynthesis and respiration. Oxygen isn't just important for life, it's also vital in industry. It's used in steelmaking, welding, and even in the production of plastics and textiles. Oxygen is also used in medical settings to help patients breathe and in water treatment plants to purify water. Its versatility makes it one of the most widely used industrial gases. Oxygen plays a critical role in space missions. Astronauts rely on oxygen tanks to breathe in the vacuum of space. Oxygen is also used as an oxidizer in rocket fuel, helping propel spacecraft beyond Earth's atmosphere. Without oxygen, human exploration of space would be impossible. Combustion, or burning, is a chemical reaction that requires oxygen. When a material burns, it reacts with oxygen to release energy in the form of heat and light. This process is used in everything from lighting a candle to powering engines. Oxygen's role in combustion is why fire cannot exist without it. Rusting is another process where oxygen plays a key role. When iron reacts with oxygen and moisture, it forms rust, a reddish-brown compound. This process, called oxidation, can weaken structures over time. Understanding how oxygen causes rust helps us find ways to protect metal objects and buildings. Ozone is a special form of oxygen made up of 3 oxygen atoms, O3. It forms a layer high in the Earth's atmosphere, protecting us from harmful ultraviolet rays from the sun. While ozone is beneficial in the upper atmosphere, it can be harmful at ground level where it contributes to air pollution. Oxygen therapy is a common medical treatment for patients with breathing difficulties. Hospitals use oxygen tanks and masks to deliver pure oxygen to those who need it, such as people with lung diseases or during surgery. This life-saving use of oxygen highlights its importance beyond just everyday breathing. Fish and other aquatic animals depend on dissolved oxygen in water to survive. Oxygen enters water from the atmosphere and through photosynthesis by aquatic plants. Low oxygen levels can lead to dead zones where few organisms can live. Maintaining healthy oxygen levels is crucial for aquatic ecosystems. Because oxygen supports combustion, controlling its presence is key to fire safety. Fire extinguishers often work by removing oxygen from the fire, smothering the flames. Understanding how oxygen fuels fire helps us develop better ways to prevent and fight fires, keeping people and property safe. Oxygen is vital for every cell in our bodies. Without enough oxygen, organs can't function properly, leading to serious health problems. Conditions like anemia or respiratory diseases can reduce oxygen delivery, making oxygen therapy or supplemental oxygen necessary for some patients. During exercise, our bodies need more oxygen to fuel working muscles. Breathing rate increases to supply this demand. Athletes often train to improve their oxygen uptake, which helps boost endurance and performance. Oxygen's role in exercise shows just how essential it is for physical activity. As we age, our bodies may become less efficient at using oxygen. This can affect energy levels and overall health. Staying active and maintaining healthy lungs can help ensure we get enough oxygen as we grow older. Oxygen's importance doesn't diminish with age, it remains crucial throughout life. The ocean is a major reservoir of oxygen. Phytoplankton, tiny plant-like organisms, produce a significant portion of the world's oxygen through photosynthesis. Ocean currents help distribute this oxygen, supporting marine life from the smallest fish to the largest whales. Air pollution can affect oxygen levels in the environment. Pollutants like carbon monoxide can bind to hemoglobin in our blood, reducing the amount of oxygen our bodies can use. Protecting air quality is essential for maintaining healthy oxygen levels for all living things. Modern technology relies on oxygen in many ways. From producing semiconductors to sterilizing medical equipment, oxygen's reactive nature makes it invaluable. Advances in technology continue to find new uses for this versatile element, driving innovation across industries. Oxygen is a key player in environmental health. It supports ecosystems, helps break down pollutants, and maintains the balance of life on Earth. Environmental changes such as deforestation or ocean pollution can disrupt the oxygen cycle, highlighting the need for conservation efforts. Climate change can impact oxygen levels in both air and water. Warming oceans hold less dissolved oxygen, threatening marine life. Deforestation reduces the number of plants producing oxygen. Addressing climate change is essential for preserving the oxygen balance on our planet. Photosynthesis is the process by which plants use sunlight to convert carbon dioxide and water into glucose and oxygen. This process not only provides food for plants but also releases oxygen into the atmosphere, supporting all aerobic life forms. Cellular respiration is how cells extract energy from food. Oxygen is essential in this process as it helps break down glucose to release energy, water, and carbon dioxide. This energy powers everything we do, from thinking to moving. Hemoglobin, a protein in red blood cells, binds to oxygen and carries it throughout the body. This delivery system ensures that every cell gets the oxygen it needs to function. Problems with hemoglobin can lead to health issues like anemia. The brain is especially sensitive to oxygen levels. Even a brief interruption in oxygen supply can cause brain damage. That's why it's so important to maintain healthy breathing and circulation, ensuring the brain gets the oxygen it needs to function properly. At high altitudes, the air contains less oxygen. This can make it harder to breathe and lead to altitude sickness. Mountain climbers and pilots must take precautions to ensure they get enough oxygen when operating at high elevations. Divers must be careful with oxygen levels underwater. Breathing pure oxygen at high pressures can be dangerous, so special gas mixtures are used. Understanding how oxygen behaves under pressure is crucial for safe diving. Pilots flying at high altitudes rely on supplemental oxygen to stay alert and safe. Aircraft are equipped with oxygen systems to ensure crew and passengers have enough to breathe, especially in emergencies. Oxygen is used in welding to produce high temperatures needed to melt and join metals. Oxyacetylene torches combine oxygen with fuel gases, making welding and cutting possible in construction and manufacturing. Oxygen is used in water treatment plants to help break down pollutants and purify water. Aeration processes add oxygen to water, supporting beneficial bacteria that clean the water before it's returned to the environment. Oxygen can cause food to spoil by supporting the growth of bacteria and mold. Food packaging often removes oxygen or replaces it with other gases to extend shelf life and keep food fresh. Oxygen is essential in energy production, from burning fossil fuels to generating electricity in power plants. Its role in combustion helps release the energy stored in fuels, powering homes and industries worldwide. Chemists use oxygen in many reactions to create new compounds, from pharmaceuticals to plastics. Its reactivity makes it a valuable tool in laboratories and manufacturing plants. Scientists monitor oxygen levels in air and water to assess environmental health. Changes in oxygen can signal pollution or ecosystem stress, helping guide conservation and restoration efforts. Every organ and tissue in the human body depends on oxygen. From the heart to the muscles, oxygen fuels all bodily functions, maintaining healthy oxygen levels is essential for overall well-being. In emergencies, oxygen is often the first treatment given to patients. Paramedics carry portable oxygen tanks to help people suffering from trauma, heart attacks, or breathing difficulties. Quick access to oxygen can save lives. As we look to the future, oxygen will remain a key element in science, technology, and medicine. New discoveries and innovations will continue to rely on this essential gas, ensuring its importance for generations to come. Oxygen is involved in renewable energy technologies such as fuel cells and hydrogen production. These clean energy sources use oxygen to generate electricity with minimal pollution, helping create a more sustainable future. In artificial environments like submarines and space stations, oxygen must be carefully managed. Systems are designed to generate and recycle oxygen, ensuring a safe and breathable atmosphere for occupants. Scientists search for signs of oxygen on other planets as a clue for possible life. The presence of oxygen in an atmosphere could indicate biological activity, making it a key focus in the search for extraterrestrial life. Oxygen truly is the element of life. From supporting every breath we take to driving technological innovation, its impact is felt everywhere. As we continue to learn more about oxygen, we gain a deeper appreciation for its role in our world and the universe. Thank you for joining us on this journey through the study of oxygen.